Alright, this is Unit 1-2 notes, and so you need to make sure that you have your 1-2 measurement note guide out with you, and you follow along and you fill in the notes as you watch this video. Alright, so there's our standard for today's lesson. So our objectives are to define the SI base units. Alright, second, meter, kilogram, and Kelvin. Explain how a prefix changes a unit and do metric unit conversions. So this is all about the metric system. And here are the essential questions we should be thinking about as we go through this lesson. Why is it important for the world's scientific community to use only one measurement system? And why do scientists use a metric system rather than the US system of measurement? Alright, so there's two types of units, okay, and the units are going to be either what we call base units, and base units are units that are independent. In other words, one single unit. So an example of a base unit here would be distance. Distance is measured with just one unit, meters. Alright, a derived unit is two or more base units put together. So these are composed units. So an example of a derived unit, if we want to measure the velocity, the speed or something, we can measure it in meters per second. So m/s. And so this is more than one base unit. So this is a derived unit. So here's a list of our base units, and we always use the SI, which stands for International Standard, and why they put it backwards, I'm not sure, but it stands for International Standard, and the International Standard is the metric system pretty much. And so here are the quantities that we measure: length, mass, time, volume, and temperature. Alright, and then here are the names of the base units we'll be using: meter, kilogram, second, liter, Kelvin. So here, for mass, kilogram is the only one, if you notice, that has a prefix. If we look here, kilogram, kilo, alright, it's a prefix, and we'll talk about those in a second. But all the other ones, if you look, are just base units. So if I look at the symbol, if I have more than one letter, like here, K, G, then I know that the first letter is a prefix, the second letter is the base unit. So if there's no prefix, alright, then these are base units. And then we'll talk more about temperature, but this is probably units we might not be familiar with: Kelvin. Alright, so let's look at our prefixes. So I need to fill in this table. Remember, if I'm going too fast, you can always pause the video to make sure you're filling these in. So that's the idea of the videos, is you pause and go back if necessary, or move forward if necessary. So as you fill this in, make sure you have the prefix and the symbol, and then over here you have the multiplier, and then over here you have the times 10 factor. This is important here. You need to know this and what symbol it goes with, and then you know what the prefix. So G's giga, capital M's mega. All right, you got lowercase m, and then micro. You need to take a close look at micro. If you notice, this right here is not a normal U. This is actually a Greek letter called mu, and if you were to draw it, it's a U with a big front leg, or a fancy looking U. So that is the Greek letter mu, and that means micro. 10 to the negative 6. Alright, so the reason is you need to know this table is so you can go from one unit to the other unit. So hopefully this is something that you've looked at before in your science classes. So here's the table. All right, I made it long ways this time, and I know that you guys were probably taught, how to memorize King Henry died drinking chocolate milk. All right, but that only gets you so far because if you look, you now have micro. Remember, micro looks like this. Greek letter mu, nano, lowercase n. Now you have giga, capital G, and mega, big M. Alright, so giga, billion, mega, million. Alright, and we see these things in computers. You go out and buy a computer, you're buying a hard drive in gigabytes, billions of bytes. Remember, bytes, unit of memory as far as computer. Or if you're buying smaller devices, the memory would be a mega, millions of bytes. All right. The micro, very, very small. Nano, even smaller. And you've heard of nanotechnology. All right. So we need to know this table, and the reason you know that is because now you got to change units from one measurement to another. So in this case, we're going to go from milliliters to liters. All right. So 2 letters. First one's a prefix. 1 letter is a base unit. So I'm going to start over here at milli. So I'm going to start here, and I want to get to the base. So if I remember the table, I'm going to move to the left 1, 2, 3 spots. It's like jumping. 1, 2, 3. And when I say jumping, what I'm actually moving is the decimal. So the decimal is right here. So I'm going to jump 3 spots. 1, 2, 3. So now my answer will be 3.770 liters. Alright? So what I'm moving is a decimal. This is why we like to use the metric system. Is all we got to do to go from one unit to the other is to move the decimal place. Now, this is one way that you can convert units, is think of this table, think of the chart, and think of jumping. Okay? That's not the only way. Alright, if that's what you're comfortable with, that's fine. But another way of doing it is looking at the power of tens and just doing a simple math problem. So instead of jumping, what I'm going to do now is I'm going to look at the prefixes. So M is milli. I'm just going to look at the exponent part, the minus 3. Milli means 10 to the minus 3. So I'm going to put minus 3. Alright. Then I'm going to subtract whatever this one is. So it's a base unit. So the exponent that goes to the base unit is 0. So it's going to be 3 minus 0. That equals minus 3. Alright, so then why did I do all this? Well, the minus tells me I move the decimal to the left, the number gets smaller. And the 3 tells me how many places. 1, 2, 3. Alright, let's look at number 2. So number 2, we're going to do it both ways. We're going to go from kilograms to grams. So this time I'm starting over here to kilo. I'm going to do G, base unit. How do I know this is a base unit? Only one letter. K is a prefix. So in this case, I'm going to jump to the right. 1, 2, 3. So where is my decimal? Right here. So I'm going to jump to the right. 1, 2, 3. Now what happens when I jump and there are no numbers here? I have to put placeholders, so I got to put zeros. So what I actually got to do here is add 3 zeros. So what happens when I add 3 zeros? Because now my answer is going to be 9,200,000 grams. So what I did is I kept the 9200 and I added 3 zeros behind it. Alright, so now let's do it the non-jumping way. Alright, so instead of jumping, I'm going to look at my prefixes. And my powers of 10. So kilo is 3, base unit 0. So I do 3 minus 0. K is 3 minus 0. Obviously equals 3. So now it's positive 3. So instead of moving to the left, I move to the right 3 places. And I get 0. Alright, let's try some more difficult ones, some that are a little more fun. Alright, so I look at this letter here, and I got this crazy looking micro, mu letter, that's Greek letter micro, so I'm way down here. I'm going from micrograms all the way up to kilograms. Now I'm going to do a much longer jump here. Okay, so I'm going to go jump. Now, if you notice, what happens to this jump? This is actually 3 places. So we got to be careful. So that's 3, 4, 5, 6, 7, 8, 9. So I'm jumping 9 places to the left. So I'm going 1, 2, and I run out. I still got to move 7 more. So I'm going to have a bunch of zeros. I'm actually going to have 7 zeros here. So I'm going to add 7 zeros in front of the decimal. So you don't so I'm going to add 7 zeros. So 1, 2, 3, 4, 5, 6, 7, 3, 7. Now, you don't have to put the 0 in front of the decimal, but you got to make sure you have 7 zeros and then the decimal. Alright? So that's one way you can jump. Now the problem is when the jumping is, you got to remember when you go from micro, nano, mega, or giga, you're jumping 3 places, not just 1. So let's look at it mathematically using the exponents. Micro, -6. So I write that -6. Then I'm going to subtract it from kilo, 3. Equals minus 9. So the minus tells me I'm moving the decimal to the left. 9 is how many places. Now I get the same answer. Alright, last one we're going to do together. Okay, I'm going to go from giga to milli. So same thing, you come up here, start at giga way over here. Go all the way down to the milli over here, and you got to count the jumps. Even though I'm jumping one spot, this is 3, 6. So I'm going 9 to 6 to 3. So that's 3, 6, 7, 8, 9, 10, 11, 12. So I'm jumping 12 places to the right. So I'm going to have to add 12 zeros. So here's my decimal. I'm going to add a bunch of zeros there. So I'm going to add 12 zeros. So I'm going to come down here and add 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright. And so I can do the same way using the math. I start at giga, that's 9. Alright, so giga 9 minus, what's milli? Minus 3. Alright, so now gotta make sure you keep track of your minuses. Because what happens here, what happens when I subtract a negative number? A negative and a negative become positive, so I actually have 9 plus 3, so that equals 12. So it's positive 12, so the positive means I move to the right 12 places, so I get the same thing. So either you can do the jumping, which is fine, or you can do the exponent addition subtraction. The key here is that you got to have this table memorized. You got to know that mega 6, micro is negative 6, and so on. Alright, now what I want you to do is hit pause and try problems 5 through 15 on your notes on your own. Alright, so hopefully hit pause. Don't look at the answers until you've done them. So I'm just going to show you the answers. Okay? So check your work, see how you did.